Hello. In this lecture, we will dive into the steps that happen to generate the keys for ikev version 2. So, don't let this busy diagram intimidate you. It's actually very simple. It is basically doing hashing and encryption. As long as you understand hashing and encryption, it should be pretty simple. In the first step, the initiator checks the Security Association database to see if there is a session. It doesn't have a session. So, it will generate a new security parameter index. This is a 64 octets random number called the SPI initiator. It will set the SPI responder all zeros, indicating to the responder that this is a new session. It will compile its security association, which is the list of encryption and hashing algorithm it would like to use, or the transform set. This list includes which Diffie-Hellman group it prefers to use as well. The initiator will then create the Diffie-Hellman public key based on its preference. It will also generate the nonce number used once initiator. It will then send the ikev2 init message. The responder would receive the message. It will determine that this is a new session. It will generate the security parameter index responder. If the Diffie-Hellman key group is acceptable as well as the proposal, it will generate its own Diffie-Hellman public key. It will generate the number used once responder. Now, the responder has all the information it needs to generate the seed keys. It will send its own ikev2 init response message, which would include its security association, its nonce, Diffie-Hellman key and a certificate request as well if applicable. The initiator gets the response for its ikev request. It will now generate the seed key. The calculation of the seed key from both sides will be exactly the same. Why? Because they both sides have the same information. They have nonce initiator and nonce responder as well as G exponent, INR, which is the shared key. It will run the pseudo-random function using the algorithm that was negotiated. In this diagram, the plus sign by PRF means that the pseudo-random function can run multiple times, until all the keys are satisfied. The keys that gets generated are as follows. The SKIDD, this is used to create child security association. We will talk about that in details in future lectures and explain what is the child SA, and create child SA. The next keys are for authentication, authentication initiator and responder. Followed by the encryption keys, encryption initiator and responder. The last two keys are new to us. This is the key confirmation key. It will be used to generate the auth payload. It will compile the information, it will send its ID, or IDI, as well as the cert if it's using certificate auth. If certificate authentication is configured, it will send the responder a list of the acceptable certificate of authorities. Now, let's talk the auth key. We mentioned it before, but we need to dive in it a little deeper. This uses the SKID PAI. The key that we mentioned earlier that is new, it is the key confirmation key. It will take the first message that was sent during the ikev negotiation and encrypt it using that key. It will send phase 2 proposal, which is Security Association Initiator 2, here in the diagram. It will also send the traffic selectors. The responder gets this message, which is the ikev auth response. The responder has everything needed to generate the exact same keys. It will do that and verify the auth message, meaning that it will take a portion of message 1 and decrypt it using the SKID PAI. Finally, it will produce its own auth and encrypt it using SKIDPR for responder. It will encrypt message 2 of the conversation. It will then compile all the payload bits and pieces and send it to the remote side, which is the initiator. So, the first payload is the ID responder, the ID that it would like the initiator to use for authentication. It will send its own cert, if certificate authentication is in use. It will send the auth payload. Finally, it will add the child SA information, which is SA responder to, traffic selector, initiator and responder. Now, the initiator gets the ikev auth response. It will do the same calculation and verify the auth. If the auth is verified, both sides hit two birds with one stone. Meaning that, phase 1 is successful and a child security association is created. Traffic can start flowing and encrypted between the two peers. Hopefully, you enjoyed this lecture. We will talk more in the next lecture.